Hello everybody. Today we're going to watch the Carsat Crisis episode 3. Again, we are very much pleased to welcome Mr. Ian Kerr to the studio. Hello, Ian.
Hello. I'm very happy to be here again.
Would you mind telling us what's the main point of the story so far and what we are going to see today?
Yes. Well, the story centers around the production of K40, a vaccine to treat the very bad disease bilharzia. The production of it is not economically possible on Earth. It requires the zero gravity found in space. And in this science fiction story of the near future, this becomes a possibility. We saw the launching of the carrier satellite, which has 12 production units or space factories, and one of these is producing K40. But a problem develops, and the motor of the pump drops to half speed. They're not sure why this has happened, and a decision is taken to try and find out what the problem is in the 9 days that are available by testing each part of the process. Last week we saw the chemical process and learned a little bit about that. This week we're going to have another flashback to the discovery of the vaccine itself.
Yes, okay, thank you, Ian. So, shall we watch the first half of episode 3?
Mary, my head's on the block. This investigation isn't an open-ended research problem. We've got a deadline.
Deadline? What a dreadful word that is. There is a time limit. Why is it your first priority to check out a well-tried chemical process? We have this whole list of things that could have caused the shutdown.
Chemical process is not well-tried as far as your vaccine is concerned. You only discovered it a few years ago.
Congratulations, Mary. It was a great breakthrough.
Oh, thank you, Danny. They're lovely, but you shouldn't.
You deserve the best. One day, thanks to you, we'll conquer schistosomiasis.
I'm afraid we're a long way from that, Elmira. We've got so far as an antigenic protein.
All. She says that's all.
No, I mean it, Danny. It's only a beginning. We shan't get much further unless we have help.
More money.
More money. Things began well. A large pharmaceutical company, BPI, took an interest in our work. They sent 2 of their executives to find out more about it. That was our first meeting with Pierre Prunier and Mr. Kluber. It was an important lesson for Danny and Elmira. Anyone who wants to succeed in scientific research must learn how to obtain financial backing.
Mr. Kluber is our financial advisor, not a biologist. Perhaps you could explain to him what you are doing, Professor Edwards.
Of course. Are you familiar with schistosomiasis, Mr. Kluber, or bilharzia, as it's also known?
I know only that it is a disease caught from wading in rivers and streams.
This illustrates the life cycle of the worms which cause schistosomiasis. Let's start with the Cercariae. They are like tiny tadpoles with forked tails. They penetrate the human skin and make their way to the liver. There, they develop into these schistosomes, which settle into the veins surrounding the intestines or the bladder. The male schistosome encloses the female and they produce eggs, about 1 egg every 6 minutes for a number of years.
Yes.
If the patient lives that long.
The eggs cause damage to the ureter, the liver, and the bladder, and other parts of the body, particularly those which get stuck in the tissues. Eventually, some of the eggs are excreted into the water where they hatch. At this stage, they're called Melicidia. Now they penetrate into the water snails. These are infected snails. In the snails, the Melicidia develop into Cercariae, and they break out into the water again.
So, more people get reinfected, and the cycle goes on.
Don't we produce drugs to treat bilharzia?
Yes, but drugs are expensive. Eradication too slow. People go back into the water, get reinfected before the disease has been brought under control.
It's generally agreed that immunization is the best answer. So far, no one has produced a suitable antigen. Or vaccine, if you prefer.
But you are making progress.
Oh, yes. Elmira, perhaps you'd like to show Mr. Kluber what we've done so far.
A traditional method of immunization, injecting dead organisms, doesn't work with schistosomes. Dead schistosomes are not very effective. Therefore, we had to find a different approach. If you look through here, you can see a Cercaria magnified. Professor Edwards took a number of protein molecules from the surface of the Cercariae and tested them on mice. One of the proteins proved to be protective. Well, that is, it stimulates the mice to produce antibodies that kill the disease. We assume that it is also immunogenic in humans.
So now you can inject people with this protein, and that will prevent them getting bilharzia.
In theory, yes. But in fact, it would be impossible to obtain enough protein from Cercariae to inject millions of people all over the world.
Ah, yes.
Nor can we manufacture an entire protein. The chain is far too long and the structure much too complex.
That's why we must go further. We must isolate a shorter sequence from the protein chain. We must find the active part of it, the part which is immunogenic. That may be only a 10th or even a 100th part of the whole. It's that part which needs to be synthesized on a commercial scale by a firm such as yours, Mr. Kluber.
I take it you're analyzing the protein.
Yes, Dan is working on it now.
You see, all proteins are built up of chains of amino acids. There are around 20 different kinds. This analysis shows us which amino acids the protein contains and in what concentration. We also determine the sequence in which they appear so that we can build up an entire picture of the molecule.
The sequence of the amino acids and their spatial arrangement determines the properties of the protein. May we see the result of your tests on the mice?
Of course. Come to my office.
These results seem to be conclusive, Professor Edwards. I congratulate you.
It's a hard task. And our financial resources are very limited. We'll also need help in synthesizing the polypeptides for our experiments.
So you'd like our company to help you do that?
It would give you a commercial interest in the product.
I should point out that selling drugs to third world countries is not very attractive commercially.
But it's worthwhile in other ways, Mr. Kluber.
I am an accountant, Professor Edwards. Besides, you haven't found your polypeptide yet. There's no certainty that you will.
True.
But the company may be prepared to assist you, even if the profit margin is low.
We cannot make an open-ended commitment at this stage.
No, but we can make a modest contribution.
A modest contribution?
To keep the professor going, out of our current research and development expenditure.
Ah, yes.
Call it an option on future rights. I suggest we talk about this matter again when you find a polypeptide which is immunogenic.
If you find it.
Harsh. Yeah. Yes. Oh, well, Mr. Kluber sounds very harsh and cruel.
Yes, he does, doesn't he?
Yeah.
But he's a businessman and
Yes,
he has
I
to
know.
protect the company.
So that's how K40 was discovered, and but they needed more money to go on, and a big pharmaceutical company, BPI, was interested in what Mary has done so far, and
Yes.
they are going to give her funding.
Yes.
Yeah? And by the way, the disease is called by two names: Systemysis and bilharzia. It's a bit
Yes.
confusing, isn't it?
It is a little bit, yes. Bilharzia is a parasitic worm, as Mary explained. It has two hosts. It lives in the human body, and then the secondary host is, in fact, the water snail.
Sorry,
Yes.
sorry, interrupting. Host.
No, that's the animal that the parasite lives in. So as we saw, it burrows through the skin of humans who are wandering or walking in the water and makes its way to the liver. There, the male and the female produce eggs, which are excreted from the body, find their way back into the water, and live inside the snail then. Eventually, the cercaria are released into the water, and again, the cycle is repeated.
I see. They hatch in the water. They're
Yes.
increasing.
Yes.
Yeah? Well, and why the traditional methods of immunization do not work?
Well, for some diseases, they've been able to give immunity by injecting with the dead organisms. I think cholera is one such disease, yes. But in this particular case, it proved to be ineffective.
Why?
They don't say why, it just was not effective. Possibly the protein responsible as the antigen was not free enough to cause the production of antibodies. So Mary, in fact, took the coat or skin from one of these parasitic worms, several of them I would imagine, and tried the various protein molecules that make up the skin, and found that they worked as an antigen.
Good, good. Well, you mentioned two difficult words, antigen and antibody.
Yes. Antibody is the substance that conveys immunity, that causes the man to fight the disease, in fact. The antigen is the substance that causes the body to make that antibody.
I see. And what is Mary's approach? I mean, you explained it already, but just
Well,
elaborate it.
She says it's too difficult to obtain enough of the protein from the cercaria, and so what they must look for is part of the protein molecule. The protein is a very big molecule, and part of that would be a polypeptide.
It's called polypeptide.
Polypeptide.
Yes.
It's a smaller part, and they believe that a little part of that protein molecule is actually what is causing the immunity or producing the antibodies. So they're searching for that. But the age-old problem, funding, money is needed.
Yes, yes. Okay, anyway, this is a horrible disease, isn't it?
It is
And of
indeed,
course,
yes.
this story is set in the near future in 1990, but do you happen to know what work is being done so far to find a cure for bilharzia?
Well, I don't know what is being done in terms of the search for the vaccine, but as they mention on the video, drugs are available to cure the disease, but the process is very slow, and the problem is that people, having been cured, wade back in the water again and contract the disease once again. So they need something that will eradicate the disease completely.
Immunization is the best way
That's
to
the
cure
way.
that disease, I see. Okay, thank you, Ian. So, shall we go ahead, watch the rest of the episode 3?
Morning, Danny.
Morning. I'm sorry I'm late, Mary. I overslept. I didn't get to bed until the early hours this morning.
Another party?
No, not exactly. I was reading a paper called The Antigenic Properties of Short-Sequence Polypeptides, okay? A bit dull, but instructive.
I should read my work, Danny. I've selected some candidate polypeptides.
But how do you decide which to choose?
Experience, of course. And blind hope. Your guess could be as good as mine. Which one would you choose?
Oh, so this is like picking a winner in a horse race.
The pharmaceutical firm helped us by synthesizing small quantities of the polypeptides that we had chosen for further experiment.
They're all here. Very efficient.
Oh. Why do I have to waste my time lecturing to idiots?
Because if you didn't, you wouldn't have postgrad idiots like Elmira, us, to work for you.
You have a point there, Danny. What's this?
It's just arrived from VPI.
Excellent.
All we have to do now is find the winner, if it's there.
start testing right away.
4043.
A32, dose 50 micrograms. It was a very long process. In order to boost the immunogenic effect of the polypeptides, we attach them to an adjuvant and a large molecule, which acts as a carrier and is non-toxic. It would be safe to inject into humans, if we ever got that far. In several cases, the mice developed antibodies, but when we challenged them with Cercariae, they developed schistosomes. They had responded to the polypeptides, but were not protected against the actual disease. We're not very good at picking winners, are we?
Perhaps one of our sequences is right, but the structure is wrong, that's all.
I'm afraid that's where everybody fails when they try to synthesize antigens. Unless the polypeptide folds in exactly the same pattern as it does in the original protein, it may not protect against the disease.
What can we do about it?
I'm afraid nobody has discovered a way to create the right configuration in the laboratory. It's as if we failed, like everyone else.
Oh, hello. What brings you here?
Saw the light on. Does Mary know about this?
No, and there's no need to bother her unless it works, huh? Syringe, please. Make a note. 500 micrograms.
500?
That's right. And market sequence K40.
Still can't believe it.
Oh, you beautiful little creature. Not one schistosome in your body.
K40, that was my favorite candidate. What made you try a dose as big as 500?
You did. In a paper you wrote, you said, a short polypeptide was less likely to be antigenic than a complete protein.
Of course, that's why I put it up to 250.
I thought maybe even that wasn't enough, and I doubled it.
Clever of you, Danny.
I'm not just a pretty face, you know.
And what's more, the configuration must be right.
For sheer luck.
Shh, there's no need to tell anyone that.
We'll test it again and again. Then when we're quite certain, we'll inform Mr. Prunier. And this is the polypeptide that we've labeled K40. As you can see from the papers I've submitted, we've repeated the experiment with 20 mice, each time with positive results. What we need now are supplies of K40 for toxicity tests, first with primates and then with human volunteers. If these are successful, we can then go on to a full-scale field trial.
Thank you very much, Professor Edwards. I think we're all very impressed with your results so far.
I must point out that trials are expensive and you can never guarantee success.
But there is a very good chance in this case.
There is another matter I should mention. We had difficulty synthesizing K40. Oh, I can supply enough for clinical tests, of course. But there might be problems in producing it commercially.
You mean it wouldn't be economically viable?
I can't say for sure at this stage.
I do hope, gentlemen, that you will go ahead in view of the potential benefit to mankind.
We're here.
Good afternoon. You wish to examine our process for synthesizing polypeptides, I believe.
Dr. Markowski would like to do so.
What do you hope to find?
Any possible reason for the breakdown in our space production unit?
How could our process be the cause of the breakdown?
Well, if there was an impurity in the base product...
Impurity?
I said if. If there was an impurity, it would have built up in one of the tubes and caused a blockage in the system.
Of course, we realize that it's highly unlikely.
You do understand that when we build up a polypeptide chain, we test the product at every step.
What is more, in this case, the two chains we synthesized were were purified and thoroughly tested before they were hermetically sealed for the space flight. Our tests showed that there were no impurities in the base products. We are a pharmaceutical company. We do not tolerate impurities.
I understand that, Dr. Mann.
Gentlemen, no need to argue. Let us show you the process in action, and you can judge for yourself.
Fine.
You know, Pierre, that day I first spoke with your directors, I never thought they'd go ahead with this project. It was a critical moment.
Yes, if I remember well, half were in favor and half against.
Yeah, that Mr. Kluber was against. So much concerned about the financial risks.
Ah, you mustn't be too harsh on financial advisors. They are very necessary, you know? As a matter of fact, it was Kluber who tipped the balance in your favor.
Kluber?
Yes?
In my favor?
Mm-hmm. He said we should take financial risks on humanitarian grounds.
Well, I found the ending very attractive, and Mr. Kluber was the most unlikely person to take financial risk in favor of Mary, but he tipped the balance in the meeting on humanitarian grounds.
Yes, he did indeed. It just shows you appearances are deceptive. Huh? Not quite the hard, cruel businessman he appeared.
It's lovely, isn't it? Well, we get back to the story, and would you explain a bit more about their research and their frustrations and success, final success,
Yes,
please?
well, as we saw, they were trying to test part of the protein molecule because the protein was just impossible for them to manufacture. And they knew what polypeptides made up the protein, and they knew the different sequences that were available. So they just tried all those particular sequences, but without success. And I think we saw Mary very close to tears there when she realized that everything had been tried. The problem actually with the polypeptide was that because it was removed from the protein molecule, its shape or configuration would be changed and then became ineffective. That's what she believed anyway. However, as we saw, Danny had read one of her papers, and he realized, yes, indeed, he realized that possibly because the polypeptide was just a short chain molecule, it would be less effective than as part of the protein. So he doubled the dose and was successful.
Yes, that's good.
Mary had already upped the dose. She'd made it a lot more than expected, but by doubling it, he was lucky enough to come up with an answer.
Yes.
Blind hope was mentioned, I think. And, but of course, it isn't always just luck. There is a very famous phrase in science that luck favors the prepared mind. Chance favors the prepared mind. So obviously they knew what they were about.
And I liked their relationship, working relationship very much. You know, Danny and Elmira, and you know, they are calling each other by their first name, but when they talk to the outside people, they use, for instance, Professor Edwards instead of Mary. But you know, in the love, their relationship is very free and amiable and you know, good.
Working together on a problem usually brings people together. And they shared their frustrations and their successes, so that a good relationship developed.
Well, we go further back at the beginning of the story. Stan and Mary was in a car, do you remember? And they were arguing. And do you remember what they were talking about? And I think Mary didn't like to investigate that the VPI pharmaceutical company.
Well, Stan suggested there might be an impurity, but Mary knew, of course, that they'd taken every precaution. And you saw that Mann, the chemist of VPI, was somewhat outraged at Stan's suggestion there should be impurity.
But Mary was on the side of the pharmaceutical company
yes,
because she's been working with them for long.
And she knew what the process was, and she knew that they had taken a great deal of care at each stage, and that there couldn't possibly be any impurity during their part of the production.
Well, again, I jumped into another subject, but do you remember in the laboratory, Mary came back from the class and she said, why should I teach idiots or something like that? She hates teaching. Yeah.
Well, I would imagine that many teaching research workers have to do that, of course, in order for them to obtain their bread and butter. But their real love is the work that they're involved in, and they have to do both things. But I'm sure once she was back in the laboratory,
and I liked that Danny's response to her remarks. If you don't teach, you couldn't get postgraduate idiot like us or something like that.
Yes, indeed.
Yes. So, would you like to say something a bit more about this story, or to elaborate? Or?
I would have thought we were running out of time.
Oh, yes, you are
Perhaps we
quite
should say
right.
goodbye.
Well, thank you.
Okay, bye-bye.
Bye-bye. Thank you.